of where things are positive on our coordinate plane. So you guys remember we have our little acronym, all students take classes. Right? So this tells us that in this quadrant, everything is positive, right? What's positive in quadrant 2? Sine. As well as its reciprocal, which is cosecant. Good. Okay. And then in quadrant 3, what's positive? Right? And in quadrant 4? Good. Okay. So, quick review questions here. It says, in what quadrant is sine less than 0? Sine less than 0 means negative, right? And cosine greater than 0, which means positive. Okay, well, in a coordinate plane or on our unit circle, where is sine going to be less than 0? Where is it negative? Quadrants 3 and 4. Okay, so we know it's got to be in the bottom half. Okay, and then for cosine, they want to know where cosine is positive. Where is cosine positive? 4, right? 1 and 4. So the only overlap here is at 4. Okay. Then number 2 says, in what quadrant is cosecant of theta greater than 0? So again, that means positive, while tangent is less than 0, which means negative. All right, so cosecant of theta. Where is cosecant positive?
1 and 2.
1 and 2. Okay, so we're looking at the top 2. And where is tangent negative?
2.
2 and 4, but 2 is the overlap. Good. Okay. All right, then they remind us of our ratios over here. Sine being opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And then they remind us that cosecant, secant, and cotangent are the reciprocals. So basically flip them over, right? They are saying that can also be written in this way. So saying that cosecant is hypotenuse over opposite is the same as saying that it's 1 over sine. Right? Because whatever number I had here, let's say sine was the number 3. I can put 3 over 1, right? And if I flip 3 over 1 over, it looks like that. So that's why that's true, right? So you can write it as the actual ratio flipped over, or you can also just write it as 1 over sine. Okay? Same for your secant. That could also just be 1 over cosine. And cotangent could also be written as 1 over tangent. All right, so keeping that information in mind, it says, given that secant of theta is equal to 4, find the values of the other 5 trigonometric functions. Okay, so secant, again, this could always be written over 1, right? Secant is the reciprocal of which one? Cosine, okay. So that means that which side is 4? The hypotenuse, good. And which side would we label 1? Adjacent side. Okay, so then I'm just missing the opposite side over here. And how could I find that? Pythagorean theorem, okay. So I'd have 4 squared minus 1 squared.
15, so root 15.
So root 15. Okay. So what would my ratio for sine be? Right? Okay, and cosine would be 1 over 4. And tangent? Right, or just root 15. Okay, and then cosecant would be 4 over root 15, but we can't leave it like that. How do I fix it? Multiply, and we end up with
4 root 15 over 15.
Good. All right, and then we were given secant. They told us that one was 4 over 1, or just 4. And then we need to give cotangent. What's that one going to be?
Root 15 over 15.
Nice. Okay, so there's our quick review there. Okay, now it says if tangent of theta is equal to -5/4 and cosine is greater than 0, find the 6 trig functions. So we also have talked about this. This tells us where we would be able to graph this, right? So tangent is negative, right? So which quadrants are possibilities for us? 2 and 4 would be our possibilities because here it's positive and here it's positive and tangent's negative in this problem. All right, so that narrows it down to 2 and 4 for us. Okay, and then I'm asked where is cosine greater than 0? In other words, where is cosine positive? Well, out of those two, that narrows it down to quadrant 4. Okay, so I'm going to draw my right triangle in quadrant 4. All right, and I know that my y value is what?
Negative.
And what number would it be?
-4.
So remember, tangent is y over x, right? So this would be -5, right? And then this would be +4. We do know that the 5 is negative in this quadrant, so that lets us know which one of those numbers was negative based on the quadrant it landed in. All right, and now we would need to do Pythagorean theorem to figure out what our r is, right? So we're going to have -5 squared plus 4 squared, which will be 41. Right, and the hypotenuse would need to take its square root, right? So this would be square root of 41 for our hypotenuse, okay? All right, so now I've got all my sides. They want sine of theta. What is our sine going to be? Good. All right, and what would our cosine be?
4 root 41 over 41.
Good. And they already gave us tangent, right? Okay, what would my cosecant be?
Root 41 over 5.
Okay, and one of those values is negative, right? So I'm going to put a negative in front of my fraction. Good. All right, and then what would my secant be? Good. And then lastly, my cotangent would be, all right, so flip it over on the back. And we got a couple more like what we just looked at. I want you guys to do those 2 there. And then we're going to share our answers out. I'll give you just a minute to fill those in. Awesome, thank you.
Yeah, we are. Is that why you got none of them? Hey, chill, I got all of them too. I got all of them. No, you did not. Well, let's see. The attitude. Attitude, what?
Oh, no, you're so right. Okay.
Mm-hmm.
When I say an imaginary number, the negative thing inside the radical.
The negative has to be inside the radical for it to be an imaginary number. Okay, so on example number 3, guys, which quadrant did we draw our triangle in? Quadrant 2, good. All right, so it looks something like this. Okay, and they gave us sine, so we knew y and we knew r. And then you guys did Pythagorean theorem, and we found that the side x was what length? Good. All right, so what did that make our ratio for, since sine was already given, cosine? Square root of 5 over 3. Okay, oops. And what do we know about that side that's measuring square root of 5? If we're in quadrant 2. It's negative, right? So I need to put a negative with that ratio, right? Okay. What's tangent? Good. Negative 2 square root of 5 over 5. Nice. Okay. What is cosecant? 3 over 2. Good. And what is secant? Good. And cotangent? Very good. Okay. All right. For example number 4, which quadrant should that one be in? 3. All right. And then for this one, we were given tangent. So that would be our y and our x. And in quadrant 3, what do we know about the values of y and x? They're both negative, right? That's why it was positive in the ratio, because 2 negatives make a positive, right? Okay, and what would be the length of our hypotenuse? Square root of 58. Okay. All right, so now that we have our side lengths, yeah. Were you raising your hand? Y. This is, oh yes, they are, thank you. This is our y value over our x value. So this should be the 3, this should be the 7. Thank you. All right, so for my sine, what should my sine be? Good job. All right. What should our cosine be?
Negative 7 root 58 over 58.
Good. And tangent was given. What's our cosecant?
Negative root 58 over 3.
Good. And secant?
Negative root 58 over 7.
Good. And cotangent.
7 over 3.
Nice. So here, the only ones that can be positive are tangent and cotangent because we're in quadrant 3, right? Okay. All right, so there's our review of those. On the practice that you're going to get, it'll have some of this. It's also going to have some of that information that we just filled out on our chart, right? And remember, I don't expect you to draw a picture if it's one from our chart, right? Because they are repetitive over and over and over again. So if I ask you for sine of 5 pi 6, and you already have quadrant 1 memorized, you just need to think, okay, what quadrant is 5 pi 6 in, and does that make sine negative or not? Okay? All right.